Jai Hind students. So in the previous section what we have discussed was the acceleration due to gravity, and then we have discussed the expression for the acceleration due to gravity, and obviously we have also discussed the factors on which the value of acceleration due to gravity depends. And also students, during the free fall of a body we have discussed how the kinematic equations of motion can be changed by replacing A, which is the acceleration, with small g, which is the acceleration due to gravity. During the vertically upward motion, A is to be replaced with minus g, while during the free fall in the downward direction, A is to be replaced by plus g, right? So based on those equations, we will be trying to solve these numericals, right students? So let's start with the first question. First question is, students, a stone is thrown vertically upward with an initial velocity of 40 meters per second. And students, again I must insist, first read the question very carefully and then write down the information and make use of any one system of unit, right? So a stone is thrown vertically upward with an initial velocity of 40 meters per second. Now we are aware initial velocity is represented by u. It's given to be 40 meters per second. Find the maximum height reached by the stone. Okay, h is to be determined. And then what is the net displacement and the total distance covered by the stone? Okay, right. And g is to be considered as 10 meters per second square. Look students, if the value of small g is not given, then you are supposed to make use of the value of small g as 9.8 meters per second square, right? Here in this question it is given that g is to be considered as 10 meters per second square. Okay, this is the situation. So this is the ground and a stone is thrown in the vertically upward direction. This is the initial velocity, 40 meters per second. As we are aware, when a body is thrown in the vertically upward direction, then what happens is its speed will keep on decreasing. It will follow the same straight path, but its speed will keep on decreasing. And eventually and ultimately, on reaching the highest point, the body will momentarily stop. That is, if this is point 2, this is point A at the highest point, suppose it has attained maximum height h. So at the highest point, its final velocity will become 0. And thereafter, it will tend to retrace its path in the opposite direction. Clear students? So we are supposed to find out the maximum height reached by the stone. So h is to be determined. So u is given, g is given. So I think v is also given. At the highest point, v is 0. Right? We are considering motion from O to A. So consider motion of the body from O to A. So try to connect these four. We can make use of third equation of motion. So third equation of motion is 2as is equal to v square minus u square. This is the third equation of motion. Here in the vertically upward motion, a is to be replaced by minus g. So we get 2. A is to be replaced with minus g. In place of s, the total height gained is h. Final velocity at point A, we are considering the motion O to A. O is the initial point, A is the final point. Final velocity at point A is 0. And it is u square. Clear students? Now let's substitute the value and we'll get the desired result. So 2 multiplied by minus g is to be taken as 10. H is to be determined. 0 square would be 0. Minus u square, 40 square. That will give us 1600. So h would be equal to minus 1600 divided by 10 multiplied by 2 with negative sign. This negative get cancelled. So we get 8 meters. Clear students? So the maximum height attained by the stone in this case would be 8 meters. So first part we are able to do. Second part is, what is the net displacement and the total distance covered by the stone, right? Total distance. So total distance covered would be total distance covered. Now as we are aware, as it reaches the maximum height, its final velocity will obviously become 0. But thereafter, due to Earth's gravity, what happens is it will come back to the Earth, retracing the same path but in the opposite direction. So now it will come back like this. And in case any other force is absent, if the body is only and only under the influence of force of gravitation, it will tend to follow the same straight path. And it will strike with the same velocity as that of its velocity of projection. This is an ideal scenario when the air resistance is considered to be negligible. Right, students? So, the ball or the stone will go to the maximum height and then it will retrace its path in the opposite direction, and again it will come back to the same point. So, distance is the total length of the path covered. So, this distance we have calculated is 8 meters. So, 8 plus 8. So, total distance covered would be 16 meters. What about total displacement, students? This we are aware. If the initial and the final position coincides, then the displacement is always 0. As just now I have stated, in the absence of any other force except gravitational force, the body will tend to move along the same straight path. It will retrace its path in the opposite direction, and finally again the body will come back at point 2. So in this situation, throughout the journey, the initial position coincides with the final position, and thus displacement would be 0. Clear, students? So we are over with question number 1. Now let's try to move forward to question number 2. So question number 2, students. A ball is thrown vertically upwards with a velocity of 49 meters per second. Calculate the maximum height to which it rises, the total time it takes to return to the surface of the earth. Right? So second question is similar to that of the first question. Here, in place of stone, a ball is given and the value of sponge is not given. So it is to be taken as 9.8 meters per second square. Fine, students? Okay. So what are the given information? Initial velocity, it is 49 meters per second. So the same situation, this is the ground. A ball is thrown in the upward direction with initial velocity of 49 meters per second. Suppose this is point 2. As it attains height, its speed will keep on decreasing. It is shown by arrows of smaller length. And eventually at the highest point, suppose it is point 8, its final velocity will become 0. So this edge is to be found. And thereafter I have stated, it will retrace its path in the opposite direction, isn't it? So, A is minus G over here. It is minus 9.8 meter per second square. Right? And H is to be determined. And we are supposed to find out the maximum height to which it rises. So, H is to be determined, and consider motion of the body from O to A. O is the initial point and A is the final point, right? Initial point, the initial velocity is 49 meters per second. At point A, which is the final point, the final velocity is 0. So, the kinetic equation of motion connecting these three, I think, would be the third equation of motion, which is 2as is equal to v square minus u square. So again, 2 in place of a, it will be replaced by minus g. It's in the upward motion. The speed is decreasing, so it is the case of retardation. So it is minus 9.8 into s h. It is to be calculated. Final velocity at point A is 0. Initial velocity is 49. Right, students? So let's solve it. So h will be equal to minus 49 square divided by minus 2 into 9.8. Minus minus get cancelled, isn't it? This decimal, it can be written in this particular manner as well. Divided by 2 into 98. Clear, students? 49, 2 is 98. So what you get is 490 divided by 4. So it will be equal to 1. 1 to 2.5 meters. Clear, students? So this is the maximum height which the ball will attain when it is thrown in the vertically upward direction. Now let's consider the second part. We are supposed to find out the total time it takes to return to the surface of the earth. So what to do is, students, please note down this point. The time taken by the body or the ball to move from O to A, that is known as time of ascent. O to A. Time taken by the body to move from O to A. It is known as time of ascent. And the time taken by the body to come back from A to O, it is known as time of descent. And students, in the ideal scenario, when air resistance is considered to be negligible, when the body is only and only under the influence of force of gravitation, in that case, the time taken by the body to gain height from O to A would be exactly equal to the time taken by the body to reach the earth from point A. That is, the time of ascent is always equal to time of descent. That is, time of ascent is always equal to time of descent. Always remember it. This is a very, very important point. Right? So, here we are supposed to find out the total time it takes to return to the surface of the earth. So, there are two methods of doing this particular question. I'll discuss both the methods. Now, it's your wish to follow any one of the methods. Right? First is, let's find out the time taken by the body to reach from point O to A. Right? So, for that, what to do is consider motion O to A. We are considering the motion O to A. Right? Here, we can consider H is known to us. It's 122.5 meters. Just now we have calculated. Right? So, we can, U is given. So, S equals to UT plus half AT square. That can be used. Right? Or V is equal to U plus AT. That can also be used. So, let's make use of the first equation of motion. Final velocity at point A is 0. Initial velocity is 49. A is to be replaced by minus G, that we have already discussed. And this T is to be determined. T is O to A. So, students, 9.8 T O to A, it would be equal to 49. Am I clear? So, that will give us TOA, it will be equal to 49 divided by 9.8, or it is 490 divided by 98. Clear, students? So, it can be written as 10 divided by 2, that is 5 seconds. Am I clear, students? It's absolutely clear. So, time taken by the body to move from O to A is 5 seconds. Therefore, the time taken by the body to come back from A to O would be also 5 seconds, because time of ascent is equal to time of descent. Therefore, T A to O would be also 5 seconds, and therefore total time it will be equal to TOA plus TAO is equal to 5 plus 5, that is 10 seconds. So the total time taken by the ball to return to the surface of the earth would be 10 seconds. Time of ascent is 5 seconds, time of descent is 5 seconds. So the total time of flight, the time during which the ball stays in air, it would be 10 seconds. Now the same question or the same part can be done in alternative way as well. We'll discuss that also, right? So let's consider the motion. Consider the motion from O to A and then from A to O. Means we are dealing with this one. We are considering the entire journey, right? O is the initial point, O is the final point. In this case, we have considered motion from O to A only. In this case, we are considering motion O to A and then again back to point O. Here, the displacement is 0. Obviously, the body is coming back to the same point. So, displacement is 0. So, here we can make use of second equation of motion. S equals to ut plus half at square. Displacement throughout the journey of this body is 0. U is 49 t plus half. A is minus g, that is minus 9.8, and this is t square. And this t, student, it is the total time of flight. This t is the total time of flight, the total time during which the ball remains in air, right? So what to do is, you can solve it. So it will be equal to 49t minus 4.9 t square. Or in other words, we can write 4.9 t square is equal to 49t. Therefore, t would be equal to 49 divided by 4.9. So it will be equal to 10 seconds. So total time taken by the ball so as to reach the surface of the earth again, that is time seconds. It is also known as time of flight. So students, it's entirely up to you to either follow this method or this method. Both are correct. It's entirely up to you. Clear, students? So now let's start question number 3, right? Question number 3, it's also based on the kinematic equations of motion only. A stone is released from the top of a tower of height 19.6 meters. Calculate its final velocity just before touching the ground. So again, it can be done in a similar manner. In this case, it is released. Now students, I told you earlier also, if a body is released like this, it's not imparted any initial velocity, it's simply released. So its initial velocity would be 0. Now height of the tower, it is given to be 19.6 meters, right? It's given to be 19.6 meters. Calculate the final velocity. This v is to be calculated just before it touches the ground. So it's relatively simple. U is known to us, v is to be determined, S is also given, right? And A during the vertically downward motion, it is to be replaced by plus g, and it is 9.8 meter per second square. 9.8 meter per second square, right? So what to do is, let's make use of, I think, the third equation of motion. That can easily give us the answer. So third equation of motion is 2as is equal to v square minus u square. So let's substitute the value 2. In place of a, we will substitute as 9.8. In place of s, we will substitute as 19.6. V, this final velocity at this point is to be determined, and initial velocity is 0. The body is released from a height. So what you get is v square, it will be equal to 2 into 9.8, that is 19.6 multiplied by 19.6. So v would be square root of 19.6 multiplied by 19.6. So it is 19.6 meter per second. So the final velocity with which the ball or the stone strikes the ground is 19.6 meter per second. So this was a relatively simple question. Right, students? Okay. Question 3 is also done. Let's concentrate on question number 4 then. A stone is allowed to fall from the top of a tower 100 meter high, and at the same time another stone is projected vertically upwards from the ground with velocity of 25 meter per second. Calculate when and where the two stones will meet. This is, student, a very, very interesting question. Right? Let's try to solve it. Question number 4. So this is basically a tower. Let us assume this to be a tower. This is a tower, right? And its height is given to be 100 meter. Its height is given to be 100 meter. It is given to be 100 meter, right? So one of the stone is made to fall freely from the top of a tower. Suppose this is the first one. This is the first one. It will fall following this straight line path, right? And at the same time, another stone is projected vertically upwards from the ground with the velocity of 25 meters per second. So it's like this. So this is the second one, and its initial velocity, it is given to be 25 meters per second. Its initial velocity is obviously 0. It's the case of free fall. Now when and where the two stones will meet. So what it means is, it will be like this. At t equals to 0, both the balls are positioned at their original position, and it is released and it is imparted some upward velocity. So what happens is, it will be like this. So let us consider two balls meet at this particular point. Right? So if it covers h meter, then it will obviously, the first ball will obviously cover a distance of 100 minus h meter. Clear? From the diagram, it's pretty evident. Now, initially, the two balls are placed at this position, and in time t, it will cover, the first ball will cover distance of 100 minus h, while in the same time t, the second ball will cover a distance h. Clear? So, using these information, we can construct two equations for ball 1 and ball 2. And then by using those two equations, we can easily find out the time t as well as the height h from the ground, from where the two balls will meet. Right? So let's construct the equation for 1. For the first ball, we'll make use of this equation. S equals to ut plus half at square. So for ball 1, we are considering motion from this to this, that is during time t. What is the distance covered by ball 1? That is 100 minus h. 100 minus h. What is initial velocity? It is 0. Plus half. A, consider g to be 10. It must be given. G, consider it to be 10. So here, A will be plus g. It is the free fall of a body. The body is moving in the downward direction. So A will be replaced by plus g. That is 10 into t square. So what will be the first equation? 100 minus h is equal to 5t square. Student, this is equation number 1. Clear? Similarly, let's try to construct equation number 2 for second ball or second stone. Again, we'll make use of the second equation of motion. S equals to ut plus half at square. Now for the second one, the distance covered is h. Initial velocity is 25. Time is t plus half. Here the body is in the vertically upward motion. So A is to be replaced by minus g. G as per the quotient is to be taken as 10. So A is to be written as minus 10 into t square. So what we get is h is equal to 25t minus 5t square. Put this as equation number 2. So students, these are the two equations, and by using these two equations, we can easily determine the value of h as well as the value of t. So let's solve these two equations. What to do is, we can simply substitute this value of h over here, right? So from 1 and 2, what we get is, look, 100 minus, substitute the value of h as 25t minus 5t square is equal to 5t square, right? So let's solve it. Open the bracket. 5t square get cancelled. So we are left with 25t is equal to 100, or t is equal to 100 by 25, that is 4 seconds. So students, the two stones will meet after 4 seconds. Clear? So this is the answer of one of the part. Now, at what height from the ground the two balls or the two stones will meet each other? So for that, substitute this value of t as 4 in either of these two equations. Right? From 2, let's substitute the value of t in equation 2. So what we get is, h, it will be equal to 25. In place of t, substitute as 4 minus 5, 4 square. So 25, 400 minus 5 into 16. So 100 minus 16, 5 is 80. So it will be equal to 20 meters. So student, this is the answer of the second part. So the two balls will meet at a height of 20 meter above the ground. Clear? So this was a very, very interesting question. So students, we are done with question number 4 as well. Now last question, question number 5 is left, right? So let's attempt the last question as well. Question number 5 is, a ball thrown up vertically returns to the thrower after 6 seconds. Find out the velocity with which it was thrown up and the maximum height it reaches and its position after 4 seconds. So this is also a very interesting question. This is also a very important one. Okay, this is a situation given. This is t equals 0 initially. A ball is thrown. It will move upward direction and then again it will return back. Isn't it? Here its velocity is maximum. As it gains height, its speed will keep on decreasing and eventually on reaching the highest point, its velocity will become 0. And thereafter, it will retrace its path in the opposite direction. And at the instant when the body strikes the ground, its velocity is exactly same as that of its initial velocity of projection. And these points are valid, students, when we are dealing with ideal scenario. That is, the body is only and only under the influence of force of gravitation. No other force like air resistance acts on the body. In such a situation, time of ascent is always equal to time of descent. So here the situation is initial velocity with which the ball is thrown, that is to be determined, and it is given that total time of flight, that is given to be 6 seconds. Total time of flight, suppose this is O, this is A and this is B. Total time of flight is time taken by the body to move from O to A, that will be the time of ascent, plus the time taken by the body to move from A to B. And as you are aware, in the ideal scenario, time of ascent is equal to time of descent. Since TOA is equal to TAB is equal to T, say, suppose each time of ascent or time of descent is T, then what you get is T plus T, 2T is equal to 6. So T equals to 3 seconds. So students, time taken by the body to reach the highest point would be 3 seconds, right? So the velocity with which it was thrown up. So let's consider the first part. So we can very much make use of the first equation of motion, V is equal to U plus A. We are considering the motion from O to A, right? O is the initial point, A is the final point. So what is the velocity, final velocity at point A? It is 0. What is the initial velocity? That is to be determined. What is A? It is to be considered as 10. Suppose G is to be taken as 10. Let us consider the value of G in the question is given to be 10, right? So, in the vertically upward direction, A is to be replaced by minus G. And what is the time taken by the body to move from O to A? That is time of ascent, that is 3. So, U would be equal to 30 meter per second. So, students, this will be the initial velocity of projection, right? This is the velocity with which the body is projected. Let's consider the second one, the maximum height it reaches. So, in order to consider the second one, we can consider the second equation of motion or we can consider the third equation of motion. So, third equation of motion is 2as is equal to v square minus u square. Again, I am considering the motion from O to A. O is the initial point, A is the final point, right? So, 2a during the vertically upward motion, A is to be considered as minus g during upward motion. So, minus 10. S is suppose h. This is to be found. Final velocity at point A is 0. Initial velocity you have calculated, it's 30. So, what do you get is h, it will be equal to minus 30 square. 30 into 30 divided by 2 into minus 10. Minus minus get cancelled. Thus this get cancelled. So, we get 90 by 2. That is 45 meters. So, students, maximum height attained by the body would be 45 meters. And here we have considered the value of small g to be 10 meter per second square. We have assumed that this is the value which is given in the question, right? Okay students, now let's consider the third part. We are supposed to find out the position of this ball after 4 seconds. So what we have done till now is, we have obtained the maximum height attained by the ball, and that is, in the previous part we have discussed, it is obtained to be 45 meters, right? Total time of flight is 6 seconds. That is, time taken by the ball to move from O to A is 3 seconds, and again to come down from A to O is another 3 seconds. So total time of flight is 6 seconds. Time of ascent is equal to time of descent, right? So from O to A, 3 seconds will get elapsed, and after another 1 second, the position of the body will be somewhere over here. Let us consider this to be point C. So during this, after 3 seconds, during the next 1 second, the body will cover distance from A to C, right? So this is SAC. Now consider, in order to find out the third part, let's consider motion of the body from A to C. Let us consider the motion of the body from A to C. Clear students? So in this case, A is considered to be the initial point and C is considered to be the final point. Clear? So at point A, we are aware the velocity is 0. So A is the initial point, so U is 0. At point C, total distance covered is SAC, that is to be determined. And from A to C, the time elapsed is 1 second. Clear? So, and it's in the downward motion. So A will be replaced by plus G, that is plus 10 meter per second square. Clear students? In case of upward motion, A is replaced by minus G. In case of downward motion, A is replaced by plus G. So let's make use of second equation of motion. S equals to ut plus half at square. So SAC is to be calculated. U is 0 plus half. A is to be replaced by 10 and T, it is given to be 1 second. We are supposed to find out the position of the ball after 4 seconds. So after 3 seconds the ball's position will be over here, and in the next 1 second it will travel in the downward direction. Suppose after 1 second, suppose this is the position of the ball. So during that 1 second, the body has covered distance from A to C. That's why we are taking the time as 1 second. We are considering the motion from A to C, right? So let's solve it. It will give us 5 meters. So students, this distance is 5 meters. After 3 seconds, in the next 1 second, the body has covered a distance of 5 meters in the downward direction. So this is where the ball would be after 4 seconds. So what will be its position with respect to the ground? This is 5 and this total maximum height is 45. So it will be 40 meters. So students, the position of the ball after 4 seconds would be 40 meters from the ground. Clear? Okay students, we will discuss the alternative method also to find out the position of the ball after 4 seconds, right? So till now we have discussed the first 2 parts. Let's recall it. Okay, this is the ball which is thrown in the vertically upward direction, and its initial velocity in the first part you have determined it to be 30 meters per second. This comes to be point O, this t equals to 0, right? Total time of flight is 6 seconds. So the time taken by the body to reach the maximum height, suppose this is point A, it will be 3 seconds. Time of ascent is always equal to time of descent. This maximum height, this also we have determined in the second part, it is obtained to be 45 meters, isn't it? So after 4 seconds, the position of the ball. So this is the ground. So as the ball is thrown in the vertically upward direction, it is taking 3 seconds to reach the highest point, and thereafter it will retrace its path in the opposite direction. Suppose after 4 seconds, the body is at this particular position. So this is O, this is A, this is C, right? So we are supposed to find out the position of the ball after 4 seconds. So let us consider the position of the ball after 4 seconds be C, which is at a height h dash from the ground. So this h dash is to be determined. H dash is the height of the position of the ball above the Earth's surface after 4 seconds of its projection. Right? Okay. So consider motion. Let us consider motion O to A and then from A to C. Right? A is the initial point and C is the final point. So student, O initial and C final. So this is the displacement. O to C, that will be the displacement, right? And from O to C, the total time taken is 4 seconds. So let's make use of this second equation of motion, which is S equals to ut plus half at square. Now always remember, initially the body is in the vertically upward direction. So during the vertical upward motion, A is replaced by minus G. During the vertically downward motion, A is replaced by plus G. So keep this essential point in your mind, right? So let's apply second equation of motion and let's substitute the value over here. S, total displacement in 4 seconds. It will be from O to C, that is h dash. Initial velocity, O is the initial point. At point O, what is the velocity of projection? 30. This we have calculated in the first part. T, total time from O to A to C, that is 4 seconds. Plus half. What is A? It is to be taken as minus G. The body is projected initially in the vertically upward direction. So it is minus 10. What is the total time from O to A, then from A to C? 4 seconds. So let's solve it. So what do you get is 120 minus 5 into 4 square, that is 16. So that will give us 120 minus 80. So that will give us 40 meters. So after 4 seconds, the ball will be at position C, which is at a height of 40 meters from the Earth's surface. Clear, students? So this is the alternative method. We have done third part by 2 methods. It's entirely up to you to choose either of these 2 methods. Both are correct, right? So I hope you have enjoyed doing these numericals. Students, as I've always maintained, numericals forms an integral part in physics. Without numericals, physics is incomplete. So do practice more and more numericals. Actually, I will devote another lecture also to another very good set of questions, right? Till then, goodbye and do take very good care of yourself. Thank you.